my dear Prep 1 students. Hope you are all fine today. In today's lesson, we are going to complete repeated multiplication. Let's first remember some of the rules that we took last time. We said that, for example, if I have 4 to the power of 3, the 4 here is called the base, and the 3 is called the power. And we also said that there are other names for power. I can call the power exponent or index or power. The three of them have the same meaning. We also said that if I have anything raised to the power of 0, this is always going to equal 1. So for example, if I have a negative number 2 over 3 raised to the power of 0, it's also going to equal 1. The new rule that we took last time, that was I have a fraction all raised to a power, and we said that we are going to distribute the a one time on the numerator and another time on the denominator. So I'm going to have x to the power of a over y to the power of a. So for example, if I have 2 over 3 all raised to the power of 3, this means I'm going to distribute the 3 one time for the 2 and another time for the 3. So I have 2 raised to the power of 3 and 3 raised to the power of 3, which is equals to 8 over 27. We must also remember that when I have a variable that has no power on it, this means that this variable is raised to the power of 1. And even numbers. If I have, for example, 2, this means that it's 2 raised to the power of 1, but I don't write the power when it is 1. One of the most important rules that we should take care of, if I have a negative number raised to a power. If I have a negative number raised to a power, I go and see if this power is an odd number, which is 1, 3, 5, 7, 9, and so on, or if this power is an even number, 2, 4, 6, 8, and so on. If this power is an odd number, so the negative sign will remain as it is. If this power is an even number, so this means that I will not have a negative sign and it will be cancelled. Let's go now and solve more examples. Now we are in the binder, page 2. Last time we stopped at question number 6. So let's go now and answer question number 7. Here I have 5 over 3 raised to the power of 2. So this means I'm going to distribute the 2 on the numerator and on the denominator. So I will have 5 to the power of 2 over 3 to the power of 2 multiplied by 3 over 5 all to the power of 0. When I have anything raised to the power of 0, then the answer is 1. So I am multiplying now 5 to the power of 2 over 3 to the power of 2 times 1, which is going to be equal to 5 to the power of 2 is equal to 25, and 3 to the power of 2, this is equal to 9. So the last answer is, or the final answer is 25 over 9. And let's go now for question number 8. 2x all squared times 1 over x. Okay, we said before that when I have a bracket, 2x squared, this means I'm going to distribute the 2 on the 2 and on the x. So I'm going to have 2 squared times x squared. 2 squared is equal to 4 and x squared as it is. Now I want to multiply 4x squared by 1 over x. 4x squared is as if it is 4x squared over 1. When we are multiplying fractions, I go and multiply the numerator together and the denominator together. So this is going to be equal to 4x squared over x. Now I have two variables. They are having the same base and I want to divide them together. So this is going to be equal to 4x to the power of 2 minus 1, because we know when we divide, we subtract powers. So this is equals to 4x. So my last answer here is 4x. And let's go now for number 9. A over b all squared times b squared over a squared. Again, I'm going to distribute the 2 on the a and on the b. So I have a squared over b squared times b squared over a squared. We can see that both fractions are the multiplicative inverse of each other. They are the flip of each other. And I know that any fraction multiplied by its multiplicative inverse, or any number multiplied by its multiplicative inverse, the answer always is going to give me 1. If I looked here at the choices, I don't have 1, but I have here AB all raised to the power of 0, and I know that anything raised to the power of 0 is equal to 1, so this is the correct answer. Number 10, if x equal negative half and y equal 3, then x, y equal, this is a substitution question. I'm going to take away all the x and put instead of it y. So now I know that x is equals to negative half and y is equal to 3. Here I have a negative number, so the first thing I'm gonna look at is the power. My power here is an odd number, so the negative sign is going to remain as it is. So it is negative. Distribute the 3 one time for 1 and the other time for 2, so negative 1 to the power of 3 over 2 to the power of 3, which is equals to negative 1 over 8. So my correct answer is negative 1 over 8. Number 11, if x is equal to half and y is equal to 3 over 8, then x cubed plus y equal, again this is a substitution question. I'm going to take away the x and write instead of it the half. So I have here half to the power of 3 plus y, which is 3 over 8. I'm going to distribute the 3 one time on the 1 and another time on the 2. So 1 to the power of 3, this is equals to 1, and 2 to the power of 3, this is equal to 8 plus 3 over 8, and this is equals to 4 over 8, and in the simplest form it's equal to half. So the final answer here is half. Let's go now for question number 12. If y to the power of 26 plus y to the power of 27 is equal to 0, then y is equal to, we know that any number added to its additive inverse is going to equal 0. So I want here to have a number, I add it to its additive inverse and I get an answer of 0. The only number is negative 1. Because if I have here negative 1 all raised to the power of 26 plus negative 1 all raised to the power of 27, again I have a negative number, so I'm gonna look at the powers. The power here is an even number, so this is going to equal 1. The negative sign is going to be cancelled because I have an even power. Plus, and I go now for the other one, negative half to the power of 27. 27, it's an odd number, so the negative number is going to remain as it is. 1 plus negative 1, this is equal to 0. So my correct answer here is negative 1. Hope it's clear now, Prep 1. And let's go for question number 3. Calculate each of the following, then put the result in the simplest form. 8 times half all raised to the power of 3. So this is equals to 8 times, and I'm going to distribute the 3 on the numerator and on the denominator. 1 to the power of 3 over 2 to the power of 3. So this is equals to 8 times 1 over 8, which is equal to 1. And let's go now for question number 2. Negative 3 over 4 all raised to the power of 2 times 8 over 27. Again, I have here a negative number, so I go and look for the power. The power here is an even number, so the negative is going to be cancelled, and I'm going to distribute the power on the numerator and on the denominator. So I will have 3 to the power of 2 over 4 to the power of 2 times 8 over 27. 3 to the power of 2, this is equal to 9. 4 to the power of 2, this is equal to 16 times 8 over 27. And this is going to equal 1 over 6. And let's go now for question number 3. Negative half all raised to the power of 3 times 4 over 3 all raised to the power of 3. Again, I'm going here to have a negative number, so go and look for the power. The power is an odd number, so the negative sign is going to remain as it is. And I'm going to distribute the power on the 1 and on the 2. So it is 1 to the power of 3 over 2 to the power of 3 times, I have here 4 over 3 raised to the power of 2. So I'm going to multiply, I'm going to raise 4 to the power of 2 and 3 to the power of 2. So again, I have here negative 1 raised to the power of 3, this is 1, 2 to the power of 3, this is 8, times 4 to the power of 2, this is 16, and 3 to the power of 2, this is 9. So my final answer is going to be equal to negative 2 over 9. And please don't forget the negative sign. In question number 4, I have negative 5 over 6 all raised to the power of 2 divided by 3 over 4. First, let's remember that if I have, for example, half divided by 1 over 3, to find the answer, I'm going to leave the first fraction as it is when I am dividing fractions, change the division to multiplication, and get the flip of the second fraction. So this is going to equal 3 over 2. The same I'm gonna do here. First of all, when I find a mixed number, I go and change it to an improper fraction. But let's look here at the negative. I have a negative number raised to an even power, so the negative is going to be cancelled. I have here now 5 to the power of 2 over 6 to the power of 2, and I'm going to divide it by, I'm going to change this number to a mixed number, to an improper fraction. So I have 15 over 4. 5 over 2, this is 5 to the power of 2, this is equals to 25, and 6 to the power of 2, this is equal to 36, times, I'm going to flip the fraction, 4 over 15. So my final answer is 5 over 27. Hope it's easy prep 1. And let's go now for page 3 in the binder. Question number 5. Here I have 3 rational numbers multiplied together. It is the same as the ones we did before. Again, I have a rational number 4 over 5 raised to the power of 2. So I'm going to distribute the 2 on the 4 and on the 5. As a result, I have here 4 to the power of 2 over 5 to the power of 2 times 5 over 16 times 2 over 3 raised to the power of 0, and anything raised to the power of 0, this is equal to 1. 4 to the power of 2, this is equals to 16, and 5 to the power of 2, this is equals to 25, times 5 over 16 times 1. So my final answer here is equals to 1 over 5. Now let's go for number 6. 1 over 4 all raised to the power of 2 times negative 3 over 4 all raised to the power of 2 times negative 1, 3 over 5. So again, the same procedure. I'm going to take the power and distribute it on the numerator and on the denominator. So I have 1 to the power of 2 over 4 to the power of 2 times, here I have a negative number, and this negative number is raised to an even power. So the negative is going to be cancelled. So I have now 3 raised to the power of 2 over 4 to the power of 2 times, here I have a mixed number, so I'm going to change it to an improper fraction. How do I change it to an improper fraction? 5 times 1, this is equals to 5, and then I go add 5 plus 3, this is equal to 8, so I have negative 8 over 5. 1 squared, this is equals to 1, 4 squared, this is equal to 16 times 3 squared, this is equal to 9, and 4 squared, this is equal to 16 times negative 8 over 5, and at the end I will have an answer of negative 9 over 160. Let's go now for question number 4. If x is equals to negative 2 over 3 and y is equals to negative 1 over 3, find the value of x squared plus y squared. Again, this is a substitution question. All what I do is I take away all the x and write in instead of it negative 2 over 3, and take away the y and write in instead of it negative 1 over 3. So I have here negative 2 over 3 to the power of 2 plus negative 1 over 3 to the power of 2. Again, I have here an even number and a negative number. The power is even and I have a negative sign. So the even power is going to cancel the negative number. I will have here 2 to the power of 2 over 3 to the power of 2 plus, again, I have a negative number raised to an even power. So again, the negative sign is going to be cancelled. And I'm going to have 1 to the power of 2 over 3 to the power of 2. 2 to the power of 2, this is equals to 4. 3 to the power of 2, this is equal to 9. Plus 1 to the power of 2, this is equals to 1. And 3 to the power of 2, this is equal to 9. So as a result, I have 5 over 9. And let's go now for question number 5. If A is equal to negative half, B is equals to 2, and C is equal to 3 over 4. Find the numerical value of A to the power of 3, B to the power of 2, plus B to the power of 2C, minus 8, ABC. Again, a substitution question. I am going to take away the variable and write instead of it the value which he gives me. So I have here A to the power of 3, which is going to be negative half to the power of 3 times B squared, which is going to be 2 squared, plus B squared, which is again 2 squared, times C, which is 3 over 4, minus 8 times A, later times negative half, times B, times 2, times C, 3 over 4. I'm going to find the answer of each term alone. So here I have a negative number raised to an odd power. So the negative number is going to remain as it is. So it is negative. 1 to the power of 3 is 1, and 2 to the power of 3 is 8, times 2 to the power of 4, 2 to the power of 2, which is equals to 4. And then plus 2 to the power of 2, this is equals to 4 times 3 over 4. And then I'm going here to find the answer of 8 times negative half times 2 times 3 over 4, which is going to equal to negative 6. Now I have negative half plus 3, and don't forget I have here minus a negative number, so this is going to be changed to plus 6. So the final answer I have is 8.5, which is 8.5. Hope it's clear now, prep 1, and let's go now for question number 6, and I need your attention here, please. We know that 2 times 2 times 2 times 2, which is 2 to the power of 4, this is equals to 16. What about if he gives me 16, I want to find it's 2 to the power of what? How can I find it? Simply, I can go and find the factors of 16. So if I want to find the factors of 16, 16 divided by 2, this is equals to 8. 8 divided by 2, this is equals to 4. 4 divided by 2, this is equals to 2. 2 divided by 2, this is equal to 1. So now I know that the 2 was repeated 4 times. So it is 16 to the power of 4. The same thing we are going to do in the following example. So let's go and begin. 8 over 27, this is equals to 2 over 3 to the power of what? So I'm going to find the factors of the 8 and of the 2. So let's remember now, I have 8. 8 divided by 2, this is equals to 4. 4 divided by 2, this is equals to 2. 2 divided by 2, this is equals to 1. So here I have the 2 repeated for 3 times. Before I go and put 3 here, I should go and make the factors also of number 27. So 27 divided by 3, this is equals to 9. 9 divided by 3, this is equals to 3. 3 divided by 3, this is equals to 1. And yes, the 3 also is repeated for 3 times. So here I have 2 over 3 raised to the power of 3. It's easy, just need practice. Let's go now for number 2. 9 over 16 is equal to 3 over 4 to the power of what? So again, I'm going to find 9 divided by 3, this is equals to 3. 3 divided by 3, this is equals to 1. So now I know that the 3 was repeated for 2 times. And let's go now for the 16. 16 divided by 2, this is equals to 8. Divided by 2, this is equals to 4. Divided by 2, this is equals to 2. Divided by 2, this is equal to 1. Here I have 4 in the denominator. Don't forget that each 2's give me 4. So if I have a closer look, I will find that 4 also is repeated for 2 times. So this means that 3 over 4 is to the power of 2. And let's go now for number 3. Can you pause the video and start doing it by yourself now? And then come back to compare your answers with mine. Now I have 64. Let's make it, since I have here 4, so I want to divide by 4. 64 divided by 4, this is equals to 16. 16 divided by 4, this is equals to 4. And 4 divided by 4, this is equals to 1. So I have here 4 repeated for 3 times. What about the 125? I want to know it consists of how many 5s. So 125 divided by 5, this is equals to 25. 25 divided by 5, this is equals to 5. 5 divided by 5, this is equal to 1. So also the 5 was repeated for 3 times. So I know that negative 4 over 5 raised to the power of 3. Let's go now for 1 over 4. Again, I have here a mixed number, so I'm going to change it first to be an improper fraction. 4 times 2, this is equals to 8. And 8 plus 1, this is equals to 9. So I have here 9 over 4. Of course, I know that 3 squared, this is equal to 9, and 2 squared, this is equal to 4. So this is raised to the power of 2. By practicing more, you will get used for the powers that are most commonly used. As 2 to the power of 3 is equal to 8. 5 to the power of 2, this is equals to 25. 5 to the power of 3, this is equals to 125. 2 to the power of 4, this is equals to 16, and so on. And let's go now for question number 5. 0.027 is equal to 3 over 10 over what? First of all, I'm going to change this to be a fraction. So it is equals to 27 over 1000. Now, how many times can I find 3 inside of the 27? So 27 divided by 3, this is equals to 9. Divide by 3, this is equal to 3. Divide by 3, this is equal to 1. So it's repeated for 3 times. So it is to the power of 3. And now 64%. 64%, this is equal to 64 over 100, and 64 over 100 in the simplest form is equal to 16 over 25. Again, I know that 4 to the power of 2 is 16, and 5 to the power of 2 is 25, so it is raised to the power of 2. Did you get the idea now? And let's go now for number 7. If x over y is equal to 2 over 5, then x over y all raised to the power of 3 is equal to, I'm going to repeat the same thing. I'm going to distribute the 3. So I have here 2 over 5 all to the power of 3, which is equal to 2 to the power of 3 over 5 to the power of 3, which is going to equal to 8 over 125. And number 8, if c is equal to negative 3 and d is equal to negative 5. Then c over d all raised to the power of 2. I know that c is equal to negative 3. So I have here negative 3 over d, which is negative 5, and it's all to the power of 2, which is going to equal to 3 over 5 to the power of 2. distribute the 2 on the numerator and in the denominator, so 3 to the power of 2 over 5 to the power of 2, which is equals to 9 over 25. Number 9, if a over b is equal to 0.2. The first thing I should do is, I want to change 0.2 in a form of fraction, which is equals to 2 over 10, all raised to the power of 3. 2 to the power of 3, this is equals to 8, and 10 to the power of 3, this is equal to 1000, which is equals to, in decimals, 0.008. Number 10, if x is equal to half and y is equal to 2 over 3, then x squared y squared is equal to, now it's easy for you to find this one, so I want you please to pause and go and answer this question and come back to compare your answer. Here I have x squared, which is going to be half all squared times y squared, which is going to be 2 over 3 all squared. 1 squared, this is equals to 1. 2 squared, this is equals to 4 times 2 squared, this is equals to 4. 3 squared, this is equals to 9. 4 is cancelled with 4, so the last answer I have is 1 over 9. And let's go now for question number 11 in page 4. Negative half all raised to the power of 3 minus negative half all raised to the power of 2. Again, I have here a negative number, so I go and look for the power. I have an odd power, so the negative is going to remain as it is. So I have here negative. I'm going to distribute the 3 one time on the 1 and another time on the 2. So it is 1 to the power of 3 over 2 to the power of 3. Minus, and I go and look again, I find the negative number raised to an even power. So this means that the negative sign, it's going to be cancelled. I have now 1 raised to the power of 2 over 2 raised to the power of 2. And this is going to equal negative 1 over 8 minus 1 over 4. And at the end, I'm going to have this equal to negative 3 over 8. The last question, question number 6, I have here 2 squared plus 2 squared. This is equals to 2 to the power of what? And I need your attention here, please. Do you remember when we used to find high common factor? I'm going to do the same. I have here 2 terms. I want to find their highest common factor. So I know that 2 squared and 2 squared, the highest common factor between them is 2 squared. Open a bracket, and 2 squared divided by 2 squared, this is equals to 1. 2 squared divided by 2 squared, this is equals to 1. So this is equals to 2 to the power of 2 times 2, because 1 plus 1 is equal to 2. Do you remember when we took in primary 6 that we add powers when we have the same base? Here I have the same base, 2 and 2. So I am going to add powers. This is going to equal 2 to the power of 2 plus 1, which is equals to 2 to the power of 3. So I have here 2 to the power of 3. But let's take another example on this. If I have here 3 to the power of 5 plus 3 to the power of 5 plus 3 to the power of 5. I'm going here to have a high common factor at 3 to the power of 5. Open a bracket, and 3 to the power of 5 divided by 3 to the power of 5, this is 1 plus 1 plus 1. This means that I will have 3 to the power of 5 times 1 plus 1 plus 1, which is equal to 3. Again, I have here the same base, so I'm going to add powers. So this is equal to 3 to the power of 5 plus 1, which is equals to 3 to the power of 6. So in those types of questions, all I make is this is going to be equal to 2 to the power of the 2 here plus 1. And this is going to be equal here as well, 3 to the power of 5 plus 1. Taking another example, if I have 4 to the power of 2 plus 4 to the power of 2 plus 4 to the power of 2 plus 4 to the power of 2. As you can see here, the 2, I have here the base as 2 and the number is repeated, added for 2 times. I have here the base as 3 and the number is repeated for 3 times. And I have here the base as 4 and the number is repeated for 4 times. So I'm going to take highest common factor as 4 to the power of 2, and to find it's equals to 4 to the power of what? I am going to make 4 to the power of 2 plus 1, which is equals to 4 to the power of 3. So the answer here is 4 to the power of 3. Hope it's easy. Let's go for question number 7. Complete using the same pattern. Here I have 3 over 4. The next one is 9 over 16. The next one is 27 over 64. As you can see, I multiplied here by 3 and I multiplied 9 also by 3 to get 27. So I'm going to multiply here also by 3 and I'm going to get an answer of 81. And also I'm going to multiply the 81 by 3 and I'm going to get an answer of 243. Let's go now for the denominator. I multiplied 4 by 4 to get 16, 16 by 4 to get 64, so I'm going to multiply by 4 and I'm going to have an answer of 256, and I'm going to multiply 256 by 4, so I'm going to have an answer of 1024. So here are the two terms missing in the pattern. And now let's go for question number 8. If the side length of a cube is 1.5 centimeter, then its volume is equal to, let's first remember, we said that the volume of a cube is equals to s times s times s, which is equal to s to the power of 3. I know here that the edge length or the side is equal to 1.5. Change it first to a mixed number, to an improper fraction, so it's going to be equal to 1.5 is equal to 3 over 2. Again, we said that the volume is equals to s to the power of 3. I know that s now is 3 over 2, so 3 over 2 all raised to the power of 3, and this is equals to 3 to the power of 3 over 2 to the power of 3, which is going to equal 27 over 8 centimeter cubed. The last question in this lesson is question number 9. The greatest number of the two numbers 1 over 4 to the power of 2 and negative 8 over 3 all raised to the power of 5. Here there is no need to perform the whole operation and find the finer fractions to find which one of them is greater. Just by looking here, you will find that I have a negative number raised to an odd power. So the negative number is going to remain as it is. I will have here a positive number and I will have here a negative number. And we know before that any positive number is greater than any negative number. So simply 1 over 4 all to the power of 2 is greater. Why? Because it is a positive number. By the end of this session, I would like to thank you all, Prep 1, and have a nice day.